Okay, so in this, really in the first 3 chapters of PreCalculus, there is quite a bit of overlap from Algebra 2, but then we go like a little bit further with it, okay? So it's kind of a nice part of PreCalculus. We kind of start with some familiarity, okay? But we are starting in the middle of Chapter 1. Okay, some of the first stuff from Chapter 1 you're going to see on the skills quiz, things you've already learned and I expect you to know from Algebra 2. Okay, so here are some reminders. Domain and range. I want you to have a 1-minute conversation, maybe less, with your pod. See if you can come up with your own words for what is domain, what is range. I should hear talking. What is domain? What is range? Part 4, domain.
The set input values, the x values.
The input values. Anybody else have a different way of writing that, of saying that? I like input. What did you say? Okay. Okay. X is what we put into a function. That's what we call our input. That's the domain. What numbers can we input into our function? So range. Prod 2, how would you describe range?
That would be the output values of the lines.
So the output values, we like to think of them as the y's, right? Okay, so I'm going to expect you to be able to look at a graph right now and talk about the domain and range. And as we work through pre-calculus, there will be equations that I expect you to look at an equation and figure out the domain and range. Okay, so we will start with a graph. Okay, let's look at this graph. Okay, since the domain are the x values, we need to think of that as reading left to right. The x-axis stretches from left to right. So from left to right, which x values do we have? Where do we begin? -1. Is -1 included? Yes, because there is a closed circle. And then our domain stops at 5. But since there is an open circle, is 5 included? No. The range. The y-axis runs up and down, so we need to think of our range from down to up, right? We want smallest to lowest. So our range begins here at -3, and it ends at, now, both of those would be included because we have values all the way from -3 to 3, and they are included. Okay. All right, you get a practice. You and the person next to you, or if you're in these chairs, the person across from you, you two work together on coming up with a domain and range for this, and then check it with the other partners at your pod. These arrows do mean that it keeps going.
you're taking -1 yeah. So, yeah, true. Yeah. Mhm.
You've got another 20 seconds to sort it out. Check with your other partner set if you haven't done that already.
The range for the mini.
Yeah, okay,
I mean,
yeah.
you did. Because for each going this way.
Okay, the domain. Hunter, what's the domain?
Infinities belong to infinities right.
Like all real numbers?
Negative infinity and -1. Possible.
Okay, so let's talk about why it's not all real numbers. What do you notice right here?
They're close.
They are, but is there any graph right here in this middle part? Okay, so it can't be all real numbers because there's that gap. So let's talk about that gap. That gap starts here at -1, and then,
Possible.
okay, so we go from negative infinity to -1, and then 1 to infinity. From left to right, that is where we have graph. Okay? Down to up, what's our range? Where do we have graph? Lindsay, L.
We have 0 to infinity.
And a 0 included or not?
Yes.
It is included. So we only have graph from 0 and above. We have nothing down below, so it can't be all real numbers. Okay, you're going to have some homework problems tonight where I ask you for domain and range. All right? And we will work on domain and range throughout the chapter. Okay? So we'll get quite a bit of work on it. Next up, a function. You've had lots of conversation about what a function is. I think this was on your summer packet. I know you talked a lot about it in Algebra 2. You have 30 seconds to turn to your neighbor. If there's 3 of you, all 3 of you can talk together. What is a function?
A function is
Okay, this one's a little shaky, it sounds like. You know it has something to do with a graph. I at least have gathered that from your conversations. But some of us are confused about what's special about it. Okay, who thinks they remember it?
like an equation like coordinates with the graph.
There is something specific when you talk about the kinds of equations and graphs that correlate. So from an equation, we can make a graph, right? But what's special about the graph that makes it a function is what we need to figure out. So you're on a good start. We need to figure out what's special about a function.
Is it the one element of the domain is exactly linked to one element in the range?
Okay, there is only one output for every input. Basically, an x value can only have one y value, right? And we have a test. that we use. What's that called?
Vertical line.
The vertical line test. Okay? The vertical line test will tell us if there is only one output per each input. So do you see right here how x equals 2? That's an input, has two different y values, two different outputs. That fails the vertical line test. This is not a function. Okay? But this graph right here, any vertical line that we draw goes through only once. It is a function. What about this third example? Is it a function? It is a function. It's okay if there's a portion where it doesn't go through at all. Okay? It just has to go through no more than once. Okay? I would say so this is yes, and this is yes. These are both functions. Okay? This just has a domain that is it's similar to the one that we just talked about. The domain is not all real numbers. It's kind of chunked up. Okay? But it is still a function. All right. Next topic. Okay? We have a lot of little topics to talk about in section 5. Okay? Finding zeros. Okay? As a pod, come up with what are we finding when we find a zero of a function? Okay. Jacob, what are we finding?
The x-intercepts.
We are finding the x-intercepts. Did you do a lot of work with finding zeros in Algebra 2? Yes, yes, a lot of work. That sounded kind of like you've done a lot. Okay. When we find zeros, we are finding the places where we cross the x-axis, our x-intercepts, because what is 0 there? Y is 0 there. These are the x values where y is 0. So if I ask you to find a 0, go ahead and write this down. F of x equals 3x squared plus 22x minus 16. If I ask you to find a 0, then I'm asking you to find where, what did you say, Nick? Y equals 0. Where y equals 0. Okay. Now, on Monday, I'm going to show you how to do this in your calculator, but this is a problem I expect you to be able to solve without your calculator. Okay? And you don't need to use a quadratic equation. Okay? That's not my expectation yet. All right? We have a quadratic. It is a trinomial. This is one I expect you to be able to factor. Okay? Now, I wanted to talk about this factoring problem. I don't use a particular method. I use guess and check. I think at this point, we should be comfortable enough to use guess and check. Now, if you have a method that one of your teachers taught you that you like to use, you can go for it, but I'm not going to use that up here. Okay? So, the way that I factor these, we have 3x squared right here, so I need a 3x times x to get 3x squared. All right? Now, I need something here and here to multiply to be negative 16. But we need to make sure that when we FOIL it out, those middle terms add to 22x. Any ideas? Well, what multiplies to 16? Yep. Negative 2 and 8. So if we put minus 2 here and positive 8 here, what is negative 2 times 8? Okay, what is 3x times 8? And what is negative 2 times x? Negative 2. When we add those two pieces together, we get our middle term of 22x. Okay, like I said, there we go. If you have a different way of factoring, that's fine. I'm not going to do it up here on the board. And if you need extra help, we can talk about that at a different time. Okay, so if this is what our quadratic factors to, then our zeros, well, let's talk about this first. We have two factors that multiply to equal 0. So we set both of those factors equal to 0. So x is 2/3 or x is negative 8 would be our zeros. Those are our x-intercepts. This is where this graph crosses the x-axis. So this is what your homework is going to be over this evening. I don't know if you've heard, but we have a different schedule on Monday. Our class is cut to 37 minutes. That's a lot of time. So I'm going to take 5 extra minutes right now and teach you 2 things to save time on Monday since it's getting cut out, and then we'll go over our summer packet. Okay? Okay. And this, I don't think, is a big brain buster, if you will. I want to talk about increasing and decreasing intervals. Okay. What does it mean to be increasing? What is happening to our function if it is increasing? Say it. It's going up. Okay. What's happening to our function if it is decreasing? Going down. What direction do we read?
Left to right.
Left to right. We read a graph, left to right. So we need to talk about where this function is increasing and decreasing. I want you to take 15 seconds and kind of draw that graph the best you can. Okay, so when we actually talk about the intervals and you look at your notes, you know what the heck is going on. And I give you 30 seconds to draw. First of all, let me ask you this. Are there any intervals where this function remains constant? No. What would that look like if our function was constant for an interval? Okay, it would look like this, right? There would be a horizontal piece. If there was a horizontal piece, that would be an interval where your graph was constant. Okay, so let's talk about increasing. From left to right, where does this graph begin to increase? Right here? Okay, so we're going to talk about the domain. Which x value is that? -3. So we are increasing from -3 up until x equals 0 because here we change directions. Okay, so from -3 to 0 we are increasing. Where else are we increasing? +3 to, we can call it 5, that would be fine. So then from +3 to 5. Remember, we're looking at the piece of the domain or the x values from left to right where our function is rising. Okay, so then when we look at decreasing intervals, when we go from left to right here, we are decreasing from -5 to -3 because that's where we are falling. And then also from from 0 to 3. So then on this graph, I'm going to point out a couple things, okay? Do you notice how in 3 spots on this graph, it changes directions, right? Okay. Anytime our graph changes directions, we call these relative minimums and maximums, okay? It doesn't have to be the absolute highest to be a maximum. And it doesn't have to be an absolute lowest to be a minimum. We call them relative minimums and maximums because just in that area, they are high or they are low. Okay? I don't have that option anymore. Okay. Sorry, I'm still getting used to this whole thing. All right, so these two right here, this is the coordinate -3, 0, and the coordinate 3, -3. Those are relative minimums. Because that is where the graph changes from decreasing to increasing. And I'm going to go ahead and abbreviate there for you. Okay? Wherever our graph changes from decreasing to increasing, we have a relative minimum. The coordinate 0, 3 is a relative maximum for the opposite reason. This is where the graph changes from increasing to decreasing. We'll probably brush up a little bit on that Monday, because your homework over that isn't going to be until Monday, but I at least wanted to get that out to you before the solar eclipse day. Okay? So, nice thing about having those gold sheets is this is your homework, but you don't have to write it down because you already have it written down on your gold sheet. Okay? So that's going to save us some time. Just make sure that in number 7, 8, 9, and 10, you are stating the domain and range. I'm adding that in. Make sure you practice that skill. Okay? So right now I'd like you to get out your summer packets, and I'm going to give you about 5 minutes